You may wonder why I picked a goofy angle like 53.1 degrees. That will be evident very soon. You'll notice that it's not to scale, that's not even close to 53.1 degrees. You'll also notice that for some odd reason it's a 400 meter high cliff. We're standing at the edge of, I don't even know if the Grand Canyon is that deep. It's on another world somewhere. So those are the things that you're going to have to find. Now again, as I normally do, on a test, I probably wouldn't say find VV, find VH, like you're going to have to know to find those first, right? Kind of thing. When in doubt, find components. Right? It's a good way to start. So we're going to find the vertical velocity, the horizontal velocity, time of rise, height of rise, time of flight, range, velocity impact. All the standard things to find. And really, what's the main difference between this type and, say, type number 2 over there, horizontal ground at an angle? What's the main difference? Like, yeah, it keeps falling. You could say that, like, on that one over there, the horizontal ground like this, I should draw it up here for people, whoa, for people watching at home. The original one like this, what's the vertical displacement? 0. Here the vertical displacement is minus 400. And after that, they're basically treated exactly the same, right? These ones are a whole lot simpler. The calculations are more straightforward, but really, same idea. Right. Say again? Would you add the peak to the 400? If you were to find the time of that fall, right? But the actual time of flight would be from there, right? So I will go through all that. So. Okay, we're ready to go on here? Looks like everyone's ready to go. Okay, so how do I find VV and VH? Well, I hope everyone knows how to do these already. So the VV is simply V sine theta, which in this case is 10 sine 53.1. And you're going to see exactly here why I picked that number for my angle. Because it's, oh, hang on here. Make sure you're in degrees. What's going on? Sine of 53.1. There's my problem. I get 8. Is that what you get? You're such a stickler. It's 8. And VH is V cos theta. Six. So the reason I picked that angle is because it came up with nice round integer type velocities for the horizontal and vertical component when you do a little bit around. Okay? 2 marks there just for finding the components. Do those first always. Yes? Okay. How do we find the time of rise? Time of rise. So that time up to there. What's the one thing you know at that peak right there? Someone's thinking it, I think. Vertical component is? The vertical component of the velocity would be 0, right? Because the horizontal remains the same. So yes, the VV at that instant is 0, or the final vertical velocity for that interval is 0. So I can use VF equals, not VF squared, sorry. VF is equal to VI plus AT. Which VI do I use here? This goes back to what we discussed day 1. Because I'm talking about, what was the word you used this morning, Brandy? Verticalness? Is that what you said? We're talking about a vertical, no, I don't think it was verticalness. Was it? Okay, we're talking about a vertical factor, it's time of rise, so I have to use the vertical component, which was 8. And it's plus 8 because it's up. Right? And so my t value is simply going to be 8 divided by 9.8, or 0.8 seconds. Is that good? What about the height of rise? Again, it's a vertical thing that we're talking about. I'm looking for d. Various ways I could solve this. I could solve by going vf squared equals vi squared plus 2ad. I could also go right and substitute this t in there. Which one of these two do you prefer? I think this one, right? This one seems like I'm going to have, I got squareds, I got t. It's going to be, seems to me like going to be a little longer. Plus, I'm going to be using a value that I calculated here. If I made a mistake, it's going to sort of show up over there. So let's go with this one. 0 equals 8 squared plus 2 times minus 9.8d minus 8 squared is equal to minus 19.6d. So my d is equal to only 3.26 meters. 27. Yes, Chris? So it doesn't go very high off the top of the cliff, does it? How come? Because its vertical component is only like 8, right? Gravity is like minus 9.8, so it's not very big. So it's only going to go up 3.27 meters. Everybody good so far? Okay. Total time of flight. Is the time up equal to the time down? And the answer there is no. Frowny face. How come? Because it'd be a whole lot easier if it was, wouldn't it? Okay. What do we know? Can I go back to this one here? Because I got a nice picture here. We know the time up, right? I know the time up. Go ahead, Brandon. No, can we not just add the upward displacement to that, find out how long it takes to fall, and then add it to the original time that we found before? I know, that's why I wanted you to say it. Because that's the question that I get every year. And the answer to that is, of course you can. I'm going to show you 2 ways to do it. Okay? So we're going to say the total displacement now is minus 400 plus, what was that number? 3.27. So the object is going to fall minus 403.27 meters. And then we're going to go d equals VIT plus 1/2 AT squared. The total displacement is minus 403.27. What, Brandy, is, because this is your idea, what is the initial vertical velocity? Is it 0? You bet it is. How come? Because that's the peak, and that's what it's at 0 before it begins to fall. So that makes that quite simple, doesn't it? Because otherwise you'd have something t, and you'd probably have a quadratic. I mean, let's face it, it's Thursday morning, but quadratics aren't that much fun. Okay, let's solve for this. Minus 4.9 t squared. So t is going to be the square root of 403.27 all over 4.9. I get 9.07 seconds, but what do I have to do? I have to add on this time right here, 0.8 seconds. And I can do that in my head. Why am I doing it on a calculator? Does that seem easy? No, Jason? It's right. There's nothing wrong with it. Because we're talking about, we're actually figuring out that 9 point something number is the time it takes to fall from that height there. And so when it gets to there, the vertical component is 0, right? But then you have to remember to add on that upward time, right? Oh, I've got something on here that didn't get erased. Now, I kind of call this the brute force way. Nothing wrong with it. It works. Can I show you what I like to call the elegant way of doing it? The I'm so smart, I'm going to do it this way. Seeing as there's no rounding chorus of no's, I'm going to do it. I'm going to say that the displacement is minus 400. Let me just draw a little picture here. Right? Is the overall displacement not minus 400? Yep. And I'm going to say d equals VIT plus 1/2 AT squared. The overall displacement is minus 400. From the original spot, the original location, what is the vertical component? Plus 8 upwards. So 8t plus 1/2 of minus 9.8 t squared. And I can solve for t. And I get 0 equals minus 4.9 t squared plus 8t plus 400. The only real downside to it is that it's a quadratic. If that was a 5, you know, if this was factorable, okay, no problem. Chris? You could do that. But then it would be 4.9t squared minus 8t minus 400 is equal to 0. You want to do that? That would be easier? Okay. Okay. So if you've got a fancy graphing calculator, you can plug that in and find the 0. If you have access to an online grapher, you could do it that way. Or you could do it the old-fashioned minus b plus or minus the square root of b squared minus 4ac all over 2a. Wait. Will I get 9.87 seconds? Let's see. Let's see what happens. Minus b. Let's decide to use this one here. So it's minus 8. So 8 plus or minus square root. B squared is minus 8 squared, or just 8 squared, right? Because it really doesn't matter. Minus 4 times a is 4.9. The c value is minus 400 all over 2 times a, or 2 times 4.9. Do you feel smart because you know the quadratic formula? No? Like walking down the street, do you like look at people and go, they don't know the quadratic formula? Yeah, you can tell something. I mean, if they're younger than you, if they're like in, grade 6, come on. We should do a... Okay, let's work out. Hey, what's the thing underneath the square root sign called? Anybody know? Do they teach you that in math anymore? Yeah, it's not called the thing under the square root sign. There's a name for it. The thing under the square root sign. Does anyone know what it's called? The discriminant. Did you know that? Yeah. See? Ask people in the mall. Do you know what the discriminant is? Top 5%, you guys. 8 squared. Oh, geez. What did I do? Okay. Obviously, that's going to be 64. I got 4 times 4.9 times 400. That's going to be 64 plus, because I've got negative times negative, 7840, all over 9.8. Now, do I have to do the plus and the minus? I guess I should do the square root here first, right? So 7480 plus 64, and then the square root of that is 88.9, all over 9.8. I want a positive time. The only way I can get positive time is if I add or subtract the 88.9. Add, right? So don't even worry about the negative one. So it's 8 plus 88.9, and then divide by 9.8, and what should the answer be? 9.89 seconds. What did we have before? Where is the discrepancy? Is there a rounding error somewhere? Yeah, there is. Right there, that 9.07 was rounded, wasn't it? And so was the 403.27, wasn't it? Right? Or at least the 3.27 was rounded. And I'm guessing that 0.8 seconds was rounded as well. So there's 3 errors you've introduced. Whereas this one, every number was given to you, right? No rounding at all. I like that because it makes me feel smart that I can do it that way. Really? You don't know? No? Chris likes it. Thank you, Chris. It has a certain elegance to it, doesn't it? Certain upper crustness. You do it however you like. If you want to be brute force, you know, the blue collar way.
But we will be judged.
Not. Total time of flight is this 9.89 or 9.87. How do I get range? Range is always easy. Always. Because why? Because the horizontal component stays the same. Is it 6 in this particular question? I think so, right? E bar equals d over t. 6 equals d over my time. Let's use the 9.89, the elegant version of the time. And I get 59.3 meters is where it lands. 59.3 meters out. If you're going to put a little kiddie pool of water out there that you want it to land in, you better put it in 59.3 meters. Yeah, I know. Those math people, they screw things up. Unit circle. This is applied math.
No, it's science.
That's math, in the, yeah, this is real world math. I can say that. I used to teach math. I can look down on them.
Look down on them.
You do realize I'm just kidding around, right?
No, I'm just doing.
He's got broken ribs. He's not going to fight me. Velocity to impact. Horizontal velocity remains to be 6. What about the VV? Does it remain 8? No, it's being accelerated. Now here you can be elegant and white collar, or you can be brute force and blue collar if you want, right? This one's a little simpler, the elegant version here. Let's go VF equals VI plus AT. The final velocity when the vertical component was 8, and I accelerate at minus 9.8 for 9.89 seconds. So in other words, the velocity is going to go up, be positive, and then come down and be negative. I get minus 88.9 meters per second. You could do it that way. You can go VF equals VI plus AT if you like. Put a 0 in there, minus 9.8, but you have to have the time of just the fall, which would be this 9.07 number, right? You could just do it from there, right? Then you get to put a 0 in there. Should these numbers be the same? They should. Yep. Right, so this is the total time, and this one over here is just the time from the top down. Does that make sense? Corey, yeah? Okay, so now how do I find velocity at impact? Draw this out, you guys. Don't be lazy. It takes just a few seconds. So this is going to be 6. This is 88.9. So the majority of the velocity is vertical. So you're going to have a rather large angle here, right? So b squared is 6 squared plus 88.9 squared. .1 meters per second, and of course you're going to need an angle. And as Chris pointed out when he walked in the door this morning and we were discussing this, these things take a long time. It's taken me 20 minutes. I mean, I have been explaining and pausing along the way, but yeah, they take a long time. There's a lot of parts to them. I get 86 degrees. And that would be 86 BTH, below the horizon. Right? If you're really good at these, like if you know what you're doing, how long should it take you to do a question like that? Provided, you're writing the formulas and you're making it nice and neat. How long do you think it should take you?
5 minutes.
Yeah. I would say probably maybe 6, 7, 8 minutes. Right? And that's like, you know what you're doing. Basically your time is just spent by writing and calculating. No sort of thinking time. It's going to take you a while. Simple as that.
How many answers do you have?
Oh, no more than one. No more than one. But guaranteed though, right? Like, I mean, guaranteed 100% you're going to have a problem like this to solve. It does. It's one of the. It says in the curriculum. It says you must solve these, and guaranteed on the exam too. How come? Because it's a big, it's an important thing. And if you screw up on the test, it gives you that chance for another go over on the exam. Is there anything else? Oh, I do have another sample one here. Okay, well let's get that one. Do you want to try this one? This is kind of what this is a. Yeah, try this one. Give this one a whirl right now. Well, yeah, let's just do this one. In real life, he would need another ramp here. What's the vertical displacement? How come I don't give you the height of the ramp, do I? Basically, it's 0. Does the height of the ramp matter here? Not as long as the height at the other end is the same. Right? You would think this would be the stuff that Evel Knievel's team of nerds would do. They didn't. He just said, I'll give her. See if I can make it. No. Oh, I got a bunch of stuff down here. You guys good to go? Not yet? Okay, so what I've done here is I've converted to meters per second by dividing by 3.6, and then I found the components to be 23.2 and 27.7. And the question is, will he make it? So will the range be far enough? And the only way to determine the range is to find the total time. That's really what we need to know, right? Is how long is he going to be in the air for? That's what we need to know. So that total time is going to be The vertical displacement will be 0, right? And that's going to be equal to VIT plus 1/2 AT squared. You can do it the elegant way, or you can do it the brute force way. I prefer this one. So that's going to be a vertical component of 23.2 T plus 1/2 of minus 9.8 T squared, or 0 equals 23.2 T minus 4.9 T squared. That's a T. Because we're smart people and we know how to factor out a T. 22.2 minus 4.9. T is equal to 0. Either T is equal to 0, which is true, the displacement is 0 when the time is 0 at the instant he leaves that launch ramp, or 23.2 minus 4.9, T is equal to 0. T is equal to, basically, 23.2 divided by 4.9. I'll explain that in a second. I get a time of 4.7 seconds. Does anyone want to agree with me? Yes? Now, what I would say the brute force way would be to find the time up. VF equals VI plus AT. 0, why 0? The vertical component at the peak is 0. The initial is 23.2 minus 9.8 T. T is equal to 23.2 divided by 9.8. 2.37 seconds, but that's only the time up. Therefore, the total time is 2.37 times 2, which of course is going to be 4.7 seconds, same as this one over here. Your choice how you do it. Right? I call it the brute force way. Nothing wrong with it, but you're taking the two parts and you're sort of adding them together. Or you can do the I'm smart and I know how to do this stuff, factoring. I'm going to do it this way. Either way, you're going to get to 4.7 seconds. And the last step then is to do what? The question is, will he make it? Will he go far enough? Find the range. V equals D over T. What was my horizontal component? 27.7. Giving me a range of 131.2 meters. He needed to go 120. Will he make it? Yes, he will make it. With plenty of room to spare, in fact. In fact, if he's not doing the math, he may be, if his ramp's not long enough, is he going to land sort of down the ramp? Absolutely. His ramp better be long. He could very well land where? Yeah, on the flat part of the ground, right? Could very well land like somewhere out over here, which would be certain disaster. So, the moral of today's story is if you ever jump 40 buses on your motorbike, do the math and figure out how fast you're supposed to be going before you set the landing angle, the landing ramp position. Always remember that. Oh yeah.